Okay. So if you guys remember, yesterday we were talking about correlation, right? So when we were talking about correlation, I told you that whenever you create this table or let's say matrix kind of a structure for the correlation, it gets very difficult for us to identify where is the correlation coefficient is highest. Let's say the high positive and the high negative, right? Because here you can see it is very small data set, or you can say the count of numerical type of values are very less here in our data set. Okay, so it is easy for us to understand where the high positive correlation exists. But what if my data set is bit huge? Okay, so it is going to create one huge table and we cannot sit back and check where the high positive or high negative correlation exists by checking each of the entries, right? So for that purpose, we visualize this table in the form of heat map. Basically, to read something with the help of visualization always gets easy for us. Okay. Instead of reading the numbers, you can look into the picture and judge what is the output going to be. So that's what we have done here. We just converted this table into the form of heat. Okay. Just a moment. Yeah. Since we converted this table in the form of heat map, we also understand one thing, that how these colors are getting justified according to the correlation coefficient R. Okay. Here you can see this is called as the intensity of colors. In other terms, we also say that this is nothing but the scale of a graph. Okay. Now, since we are talking about the scale, you can see the scale is starting from 0 to +1. There is a possibility that your scale can go from 0 to -1 as well. Why? Because in our case, we don't have negative correlation. You can see it's very small, kind of negligible. But suppose if in other data set we are having negative correlation as well, so we will see some color intensity for the negative direction as well. Okay. Now this table here gets converted into the heat map. If you look into the heat map carefully, I told you to ignore the diagonals because according to the matrix kind of a structure, it is nothing but the correlation checking of the similar type of columns, right? So we have to ignore the diagonals. Once you ignore the diagonals, now you have to check where else this correlation coefficient +1 or correlation coefficient -1 exists. Okay. How we are going to check that? Either you can read the values from these blocks, or what you can do is you can check for the highest color intensity. You can see the dark purple is representing to 1. So we can search for the dark purple color inside the heat map. Wherever that dark purple color exists, we can say that we do have correlation present in my data set. For example, let me deliberately create one column which is going to be correlated. It is audible, right? My voice, it's clear now? Yeah. So come back here. I'm deliberately going to create one column which is going to follow the correlation. Okay. So let's say df1.dtypes. Here, what is this? This is applicant income. Let's pick this particular column. Let's consider the applicant income is now in USD. I'm going to convert it into dollar. Oh, sorry, INR. Give me a moment. Okay, so sorry for that. So you can see this is your applicant income column. Now I'm picking up this column. I'm just going to convert it into INR. Let's say I'm multiplying it with 83. I'm not sure with the exact dollar price. So I'm just creating this and assigning it back to my DF1 data set with some new column name. Okay. So you can see I just multiplied 83 with all the column entries and assigned it back to the new column. Running it. Now I'm going to check my DF1. By the end, you will see it is showing me 14 columns because I created one extra column here. Okay. Now let's check the correlation. df1.corr. For me, it is going to work. For you guys, what you have to do is you have to write somewhat like this. Yesterday, I had given you the command, right? So you have to follow that command. Now coming back here, since I'm going to run this, you can see this is my correlation coefficient. I'm going to ignore the diagonals. After ignoring the diagonal, look where else we are finding the correlation value as +1 or -1. Now it is getting difficult, right? You cannot sit back and check each entry one by one to identify. So in that case, what we do, we directly create the heat map just to identify where, for which combination of column my correlation coefficient exists. 1. Okay. So I'm just simply doing SNS.heatmap. Inside the heat map, I'm going to pick up this particular thing, pasting it down, and then I'm running it. You can see this is creating a beautiful heat map for you. Since you're not liking the heat map, so what else you can do? You can change the color with the CMap thing. Let's say I'm going to write purples like before. Now, I'm also mentioning the A0 is equals to true, which is going to give me the entries inside the blocks. Running it. Now you can see how easy it is for us to find that applicant income and new, they both are correlated with a positive value 1. Okay, since their two columns are correlated, can we say that they are redundant in nature? Of course, because I consider this to be in the dollar, I converted it into the INR, which is giving me the correlation coefficient as 1. So since the two columns are redundant in nature, what should I do? Should I keep it or should I delete it? Of course, I'm going to delete it. Redundancy, guys, if you put such type of data in your machine learning model, your ML is very, very smart to identify that these two columns are behaving similarly. Okay. So for that instance, I can simply delete one column. How we can delete it? You remember we have one keyword called as DEL keyword, right? So this is your DEL keyword. I'm choosing it. I'm simply writing DF1 of new column, running it. Now, if you want to check your DF1 data set, your new column does not exist. Okay, so this is the whole procedure. I deliberately created one column for you just to show you how your correlation coefficient look like after ignoring the diagonal. Now, is this clear? Making sense? Okay. Come back to the point. I guess we covered bivariate categorical type of analysis. We also covered bivariate numerical type of analysis. Now, what else we need to do is bivariate with the combination of one categorical feature and one numerical feature. So we are going to do that. Okay, coming back. So when we are talking about this bivariate thing, where one column is numerical and another one is, let's say, categorical, usually we create, let's say, box plot for such type of analysis. Okay, let me draw the graph for you. Bivariate combination of numerical and categorical feature. Okay, we are coming back here. Now, what I told you that we can create the, what you can say, whenever this combination comes into the picture, whenever we want to create some insight for this combination, we create box plot. Okay. You guys remember why do we create box plot? Yesterday we talked about the box plot, right? Any idea why do we create it? What is the reason of creating the box plot? To see the outliers, right? To identify if my particular column is containing some extremely large or extremely small values which are tempering or hampering my average. Okay, coming back here, let's create the box plot. Simply writing df1 dot box plot. Don't worry guys, we are working with this data set. Once we're done performing all the EDA, we'll pick one fresh data set and we'll do all the things on one go. Okay, so df1 dot box plot, you are going to mention the columns, and here in the columns I am mentioning one numerical type of feature, let's say applicant income, and then I'm going to mention by one categorical type of feature, let's say education. So it is going to give me the outlier of applicant income on the basis of education. You can see we are having two different type of entries present inside the education. What? Your graduate and not graduate. So since I'm going to run this, you will see, wait a minute, applicant income, columns, dot box plot. Okay, it should be column. Okay, now to look into this, we are having a beautiful box plot where graduate and not graduate are two different type of boxes. Here we are getting the frequency, or let's say the label of applicant income. Now here you can see this is the 10,000, and here we can say this is the maximum value. Above this values for the graduate people, they are outliers. And here somewhere approx 8,000 above, we are having the outliers. You can also judge one thing, that we are having one applicant income who is earning 80,000 rupees, right? Yesterday we were having the discussion over it. That is this particular person who is having the applicant income extremely high as compared to rest of the people. Is this person an important person for us, or we can remove this entry? You can see that person is graduate, which means it is coming with more security, right? So let's see if it is employed or not, that person is employed or not. We can say that, right? Business is going to come into profit or loss. It is up down thing, right? But if somebody is employed under some organization, they are going to receive the uniform amount of salary every month, right? So if I'm going to run this particular thing, you can see self-employed, yes, and self-employed, no. So that 80,000 rupees applicant income person, okay, let's draw the conclusion. The person earning 80K, that person was graduate, and he is not even self-employed, which means he is employed under some company. Comes with the highest security, right? So that's how we can judge if this person can be important and can be an important customer for us or not. Okay, if let's say the situation was somewhat like it is, the person is earning 80K and non-graduate and self-employed, I will think before granting the loan. But if the person is coming with this number of parameters, turning out all to be positive, I can grant the loan. You can also check for the credit history, right? If that 80K earning person, what type of credit history it is that person is holding. You can see credit history 0.0. Okay, 1 is considered to be the good. Since the credit history is bad, still we are granting the loan. I don't know if he or she is getting the loan or not. You can check via loan status as well. So that kind of points you can consider and extract on the basis of this box plot with the combination of categorical and numerical. Okay? Is this okay? Do we have any sort of questions? Because we are jumping towards the data cleaning And after that, we will jump into the multivariate analysis. Your two type of analysis are over, your univariate and bivariate. Now we'll jump into the multivariate later after doing the data cleaning. So tell me if you have any sort of question. Yes, no, maybe. What happened, guys? Fridaying already, kya? Yes. That person, there is a possibility that he didn't got the loan. What is the reason behind that? You can see the credit history was 0, right? So on the basis of that, we can judge which feature is kind of important and impacting to my target variable. Yes, what happened? Yesterday I told you specially not to miss the session. Yesterday attendance was 15, now 8 of you joined. Very nice. Chale, shall we move forward for data cleaning? Chalo, let me give you the heading. And guys, please do understand this thing because it is very, very important factor. Data cleaning, okay? Basically, what data cleaning is? Data cleaning means removing the duplicate type of entries from the data, removing everything from the data which is of no use. Getting it? So what can be inside the data which is of no use? Simply data cleaning, we do first thing is by removing the duplicate. And the second thing what we do is dealing with missing values. Now, basically what happened, guys, whenever we receive the data from the client, whenever we are having the duplicate entries, what is the duplicate entry? Suppose you are having a table like this. You are having the entries 1, 2, 3, 4, 5, 6, and again 1, 2, 3. So what is this? You can see this entry and this entry. These two entries are very identical, right? They are matching as it is. So we can say that these two entries are duplicate in nature. Okay, so whenever we are saying that these two entries are duplicate, we also understand one thing, that every and those two rows, every column entry should match. Okay, it shouldn't be like 1 and 2 are matching, this third one is not matching. No, everything should match. Okay, so we will identify the duplicate and remove the duplicate. It's very easy, right? Because we don't have any cross questioning in that particular activity. If we keep the redundant entries, it is just going to increase the space. No other thing. Now let's talk about the missing values. How your missing value looks like. Let's say you are having the entries like this. Let's say 100, 20, and this is blank. 3, 2, 1, blank, 0, 3. Okay. Now in such cases, what happened? You can see we are having the null entry. This observation is perfectly fine, but we are having one null entry in the column number 3 for first observation. So in that case, I cannot delete this entry, right? First thing what comes into the mind, that if it is containing some empty type of value, let's delete it. So if we are going to delete such type of entries, you can see that I'm going to lose the data, right? If I'm going to delete this entry, then I have to delete this one as well. What is going to remain in my data set? Only one entry. So on the basis of one empty cell, we cannot delete the whole observation. Okay, so what we do? We usually perform imputation. What is imputation? Imputation says that we are going to fill this null value. Okay, filling null value with some statistically correct value. When I'm saying statistically correct means what? Suppose if I am describing this particular column, do you understand that? df1 column number 3 dot describe. This is going to give me mean, mode, median of this particular column. After filling these entry, the statistical overview of that column should not get changed. Or even if it is changing, it should change in the good direction, not in the bad one. Getting my point? What I'm trying to say? Suppose if I'm going to describe this third column, what will happen? It is going to give me mean, mode, median of the particular column. Now we understand that mean is equals to median, which means my data is standard normally distributed. But here in this case, my mean is somewhat, let's say 2, and my median is 3.5. Okay. Suppose if I impute this entry, that is going to change the mean to 2.5 and median to 3.5. What is happening? We are coming closer to the median, right? It is a good direction. We are going in a good direction where my mean is equals to getting median, which means we are getting close towards the column being standard normally distributed. So either you're not going to change the statistical overview of that column, or even if it is changing, it should be changing for good. Okay. So that type of imputation we are going to perform. After and before imputation, checking is very important. First, you are going to check the statistical overview of your column. And after imputing, you are also again going to check it. For what purpose? You are not disturbing the meaning of the data. Getting it? Previously, what it was, it should be the same after the imputation. Okay. So, imputation varies according to the numerical and categorical feature. For categorical, we have some different statistical understanding, and for numerical features, we are having some different statistical understanding. It couldn't be same. Okay. So, for that purpose, we are going to move forward in the direction of data cleaning, and we will understand how we can clean the data. Okay. It is not always going to be the same every time. Sometimes what happens, the client who gives you the data set also mentions that if you identify some null value, fill it with the mean of that column, fill it with the median of that column, fill it with the mode of that column. They mention it. Okay. But if they are not mentioning it, how we are going to decide how to fill and what to fill? Okay. So that is what we are going to learn. So first, let's talk about duplicates. Okay. First, we will identify the duplicate entry and then we are going to delete it. So let me give you the heading. Finding the duplicates. Okay. So for finding the duplicates, we are having one command. Let's say df dot duplicates. So duplicated. Okay. Df dot duplicated. If I'm going to run this, df1 it should be, my bad. So you can see it is giving me false, 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 true, 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 true. I'm not identifying what all observations are duplicated in nature. So for that purpose, whenever you are getting the entries or answers like this, simply write dot sum and run it. You can see what it is telling you. 0. Do we have any duplicates in my data set? No. Okay. So sum is going to do the sum of all the entries where we are getting the answer as true, right? Here we are not getting the answer as true anywhere. That's why the duplicated dot sum is printing 0 for me. But consider you are having duplicate and you want to delete it. Okay, so how you are going to delete it? It's very simple. You just need to write df dot drop, that should be df1 duplicates. Open and close parenthesis. Run it. Okay. Now guys, always understand that df1 dot drop duplicates are going to drop all the identical or similar type of call or observations. Again, once it is dropping all the similar type of observations, you need to restore it in your data set. Okay, df1 again, because the changes here which we are doing into my data set, they are not permanent, they are runtime. So whatever changes you are doing, always save back to your data set or save back to your column. Okay, do not forget that. Or unless you must be wondering that I have performed all of the things, why it is not getting saved. Okay, whenever you are doing such kind of a thing, save that again back in your variable. Then only it is going to work. Okay. So this is how you are going to drop the duplicates. Is it good? Let me give you 1 minute. Okay. Let's move forward. Let's talk about dealing with the null values. Okay. Now missing values comes with 2 different type of data. Do you understand that? One data type is going to be your categorical one. Another is going to be the numerical one. Okay. Now, what is the statistical point of view for the categorical data type? What do we find? Yes. What do we find for categorical type of features? If I'm going to draw the statistical overview of any categorical feature, what it is going to give me in that particular overview? What do you guys think? Yeah, dot describe is the method which we are going to use, right? After using dot describe, what we are going to get as the output? Attributes, mode, right? We can identify mode for the categorical feature. And similarly for the numerical, what else we can identify? Mean median, right? Mean median count, of course. Now, correct. Let's get back to the point. Now, since we are having only one opportunity of the mode, consider you are having one column. You can see here in the loan status. We are going to have some null entries. Okay, first let's identify how we can check how many null values are there. Okay, so there are two commands for that. You can simply write df1.info. You can see it is giving me total entries are 614, where the range stands between 0 to 613. Coming back, we are having total 13 columns. Let me delete this drawing. These all are your columns. Float 64, integer 64, object 8, not null count. What it is telling you? That out of 614 entries, 614 is filled. No null value. 601, null. 611, null. 599, null. Okay. So basically, why we write df1.info, it gives me the basic overview that if my data contains null type of value or not. Okay, coming back to the point, let's genuinely check what is the count of the null entry present for particular feature. So I'm going to simply write df1 dot is null. Running it, you can see again it is giving me true, 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 false, false, false. What is the thing? What I told you? Simply write sum after it. You can see now it is giving me the sum. Gender, we are having 13. Married, we are having 3. Dependents, 15. Self-employed, 32. Loan amount, 22. Loan amount term, 14. Credit history, 50. Okay. Now we are having the data type along with the count. Okay. Now consider this self-employed feature, which is categorical in nature, right? Self-employed feature, if I'm going to find the mode of this feature, how can I find df1 of self-employed? Do you guys understand why we are finding the mode? Because this is the categorical feature and this is what we can do only. Okay, simply writing dot mode, running it. You can see what it is. It is giving me the answer as no, which means self-employed mode is no. What it is, series or data frame? My output is coming in which format? Series format or data frame format? Yes, guys. My output is coming in which format? Series or data frame? It is series, right? Now we can identify that it is a series. What it is saying, self-employed is no, right? Okay. Now, what is the statistical insight? That we are having 32 null values, right? Since we are having 32 null values, do you understand one thing? If I'm going to fill these null values with no, what my answer, or if I'm again going to check my mode, what it is going to be? No again. So if I'm finding the mode before imputation, it is no. After filling this 32 entries, still it is no, which means I am not changing the statistical overview of my data set. That is what we have to stick about, right? Maybe you are getting this thing in your head, right? That self-employed no means what? That person is secure, right? That person is not carrying their own business. Cool. If that person is not carrying their own business, which means the person is receiving the uniform amount of money or salary every month. Yes. if that person is more liable to pay the loan as compared to the person who is a businessman, right? We are going in a positive direction. So no problem. That's how we decide. Okay. First we identify the mode. Yeah, there is a possibility. Okay, unless you decide the mode, you have to also think in that direction that is it positively affecting my data set or negatively affecting my data set. Okay, so that is what your mode says. Okay, once we identified what is the mode, we are going to impute. Imputation means what? Filling the missing values with the help of statistics of that particular column. So I'm going to fill these 32 entries with the no as answer. Okay. Now, how we are going to fill it? Very basic funda. You are going to simply select that particular column which you want to fill. Self-employed dot fill NA. Fill NA is a method which will help you to identify the null entries in that particular column. And whatever you mention inside the fill NA is going to get filled there in those null cells. Okay, either you can write this or you can write this. I'm writing the index position because I want to extract no. Okay, as you guys already identified, it is a series. Both of them are correct. Okay, we usually ignore this because this is the optimized one. Later there is some change in your data set, then you don't need to again recalculate it and mention it. Okay, so either of them you can choose. Either you directly mention no inside your fill NA, or you can give the command like this. Again guys, I'm telling you, it is not getting saved. This is for runtime. What you have to do, again select that particular column, save the changes in that particular column by putting 1 equals to. Okay, like this. So either of them you can choose. So I'm commenting down the first one. We are going with the second one. Running this. Okay. After running, if you again want to check, you can pick up this command and check right now what is the null entry of the self-employed. You can see 0. You want to check the mode, you can check the mode, still it is coming as no. No difference in the statistics of the data set. Look into this, observe it and let me know. fill stands for filling the null values. Okay, it is going to identify your null entries and it is going to fill whatever you are going to mention inside it. Okay, so identifying null entries and filling with the mentioned entry present inside the fill. Fill not applicable. Okay, come back here. We were talking about this fill with mode, right? So this is the categorical feature. We identified the mode of the data and we filled it. Now let's talk about numerical feature. You can see, let's go up and this is credit history float. Okay, you can see credit history is the float type of data, right? But it should be float type of data. What do you guys think? Credit history contains two different type of entries, right? 1 and 0. Okay. Although it is written in the format of 1.0 and 0.0, is it the correct format? Shouldn't it be, let's say, object type of data, right? Where I can identify the mode, and then because finding mean and median here for this particular column does not make sense, right? So you can also change the data type according to the requirement. Coming back here, let's say, if I'm going to pick the credit history, that is float type of data, okay? And I'm going to describe this. You can see what it is giving me the mean as 0.84, median as 1, okay? Now, if I'm going to change the data type of this credit history, if you guys remember, whenever we want to change the data type, I can simply write as type, right? And I'm going to change this as object, storing this in some variable X. Okay, I'm not modifying it in the data set. Now I'm describing the variable X. Okay, top unique, let's not describe it. Let's directly find the mode. Okay, so here you can see the median looks same as that of your mode. Okay, so what we have done, we changed the data type because credit history, you guys know, it is not exactly numerical type of data. It is categorical type of feature where 1.0 and 0, they are a discrete type of value, not continuous one. When something is discrete, we can directly fall them into the category of categorical feature. Okay, so either you can fill it with the median of the data, or you can change the data type of the credit history and fill it with the mode. Completely your choice. Okay, so this is your homework, guys. I filled one categorical feature. You are going to fill the rest of the categorical feature. Okay, we are going to numerical one now. I'm going to show you one numerical feature and rest of the numerical features you are going to fill it. So let's pick up the loan amount. Let's pick up loan amount. Writing DF1, describing that particular column. Okay, this is your mean, this is your median. You guys know that for the numerical columns, we can identify both mean and median, right? Now the question arises which one to fill with. You can see in the loan amount, we are having approximately 22 null entries, right? What do you guys think? What should we fill with? Mean or median? What do you guys think? Think and answer. If given a chance between mean and median of a numerical column to fill or impute the null values, which one you are going to fill it with? Mean, median, okay, mean. Those who are answering mean, let me tell you one thing. Do you guys understand that yesterday we were talking about standard normal distribution? Median is also calculated value, okay? Don't think in such a way. When we were talking about standard normal distribution, what I told you, when your data is not normally distributed or not standard normally distributed, can we say that the mean is disturbed? Getting my point? If the data is standard normally distributed, by default your mean is going to look equal to your median, right? But if your data is not standard normally distributed, your mean and median will look different. They are looking different. If I'm going to fill it with mean, it is going to be the disturbed mean, right? Am I making sense, guys? What I'm trying to say? If I'm going to, yes, of course, mean is a calculated value, so as median. Okay. What will happen when the loan amount, it is going to arrange all the entries in the series and then identify the median, centermost point of the data set. Okay. And filling it with the centermost point of the data set does not going to harm my median. Median is still going to remain constant. That is what the main motive of imputation is, right? That whatever it is, it should not get changed after performing the imputation. Before imputation, whatever my entries was, after imputation, it looks same. It looks same as that of before. And when your data is not standard normally distributed, it is very identical. That your mean is not equals to median. When it is not standard normally distributed, we identify or we understand that the mean is disturbed, right? Mean is deviated. It is not the exact one how it should be. So median is the safest point of view, or let's say safest choice for imputing the value in the loan amount column. Are you getting the point? Am I making sense? Do you need re-explanation? Do you want me to explain it once again? Or are we good? Yes, no, maybe. Okay, don't worry. You will get all the understanding once you go in the statistics module. Okay. But as of now, understand that if data is not standard normally distributed, means mean is disturbed. It is not actual mean how it's supposed to be, right? And when something is disturbed, I cannot fill with the disturbed value, rest of the values with, right? So I am picking the median as the safer side because median is the centermost point of the data. Centermost point of the data is not going to get changed. Okay. Either way, if your data is not standard normally distributed, and even if it is standard normally distributed, we are going to fill it with mean only. I'm just picking up this column, simply writing it down, dot fill NA. Inside that, pasting that column, writing the median, MEDIAN. Okay, let's check what this is going to give me the answer as. Okay, I should mention open and close parenthesis. So it is giving me the answer exact number. So I'm going to mention here exact command. Since it is not going to save the changes back to my column, so I have to mention it again like this. Running it, going back, checking if my loan amount from 22 will become 0 after the imputation. Yes, it is done. If I want to check again the statistics of this data set, I can simply copy it and check it. You can see. Previously, the mean was 146.412. What is the mean right now? 145.75. What is the median as it is? Is it coming closer to the median? Yes. 1 point something, we came closer to the median, which means we are going in a good direction. Getting the point? Look into it. Rest of the entries you're going to fill again, okay, with the median. I'm just showing you one entry. If you come on Monday, your data set should be cleaned. No duplicates, no null values. It should show 0, 0 everywhere for every feature. Look into this and tell me if you have any sort of questions. Okay. Okay. After